Okay, so this is a lesson for topic 4, lesson 2. So 4-2. We just finished up 4-1. In 4-1, we were solving systems of equations using graphing. So for example, you see I have two equations here. That's a system of equations. It means we have multiple equations that are making up one answer. Or maybe it could be more than one. I guess it defines exactly on top of the other line. We have an infinite number of solutions. But typically, when we graph two lines, we're going to have the two lines cross at one point, and that one point is the solution. That's what we had been working on. We can also solve those equations and come up with that one solution. So again, there will be one value of x and one value of y that will work for both equations. We can solve that without graphing, and that's what we're going to move on to now. And the first way we're going to do that is what's called substitution. So as we talked about, or will talk about in class, substitution just means replacing something. When you substitute for somebody in a volleyball game or a basketball game, you go in and you replace them. You're substituting for them. Well, we're going to do the same thing. We're going to substitute something in to an equation for something else. So if you look at my two values, I have my two equations. So I have equation 1 up here, the top equation, y equals x plus 1. And then I have the second equation, 3x plus 2y equals 12. Again, they are separate equations. The top equation would have one line if you graphed it. The bottom equation would have a different line if you graphed it. I am going to solve it in a different way with graphing. So what we need to do first is we need to line these equations up so that they, actually we don't need to do that in substitution, I'm sorry. You don't even have to worry about that in substitution. We'll get to that in 4-3. In this, we're just going to do substitution. So if you'll notice in the top equation, it says y equals x plus 1. Well, the short version of that is that literally, instead of using the variable y, we could replace that with x plus 1 because they're equal to each other. They're the same thing. So where you see 2 times y, so where you see this term right here, 2 times y, I'm going to say, well, you know what? I know that y actually equals x plus 1. So instead of keeping it as y, I'm going to plug in x plus 1 because then I only have one variable and I can solve. So I still am going to have, so my next step, I still have the 3x plus 2 doesn't go away. But now, instead of multiplying it by y, I'm going to substitute x plus 1, because that's the same thing as saying y. X plus 1 is equal to y. And that all is still going to equal 12. Nothing else changes. I'm literally just replacing y with what y equals, which in this case is x plus 1. Now I just kind of do the distributive property on that next step. So plus, so I'll switch colors. I'm going to do 2 times x and then 2 times 1 to do the distributive property. So that would be 2 times x is 2x, 2 times 1 is 2, and then that's still just going to equal 12. Now, if you'll notice, I have like terms. I have x's, 3x's basically, or 3x, and then I have 2x's, or 2x. So I say, okay, well, if I have 3x's and I add another 2x's to it, then that's just going to combine to make 5x. And then that's going to still be plus 2. There's nothing changed there. Just brought the 2 down. 12 just comes down as well. My next step is just to solve it. I want to get the x all by itself. So I need to say, okay, well, in order to get the x all by itself, this would be step 4 if you're using your sheet that solves equations. So I need to say, okay, well, the next step is that I'm going to take this 2 and get rid of it because I want to leave the variable for last. Division, remember, is normally the last, or pretty much always the last thing. So I'm going to save that division part for last. So I subtract 2 and I get 0, but if I subtract 2 there, I better subtract 2 over here. So I have 5x, which I'll just bring down. I didn't do anything with that. I get rid of all of that, so I don't need that anymore. I subtracted 2 over here, so I have 10 left. So now my last step is I divide by 5. Here, I'm going to do this in a different color. I'll do it in blue. So I divide by 5 here to get rid of the 5. That'll cancel out or divide out to 1, which means I need to divide over here. Oh, I didn't do this, but I should start doing this. So that's my middle of my seesaw, or the middle of my equation. So whatever I do on the left side, I need to do on the right side. So I subtracted 2 on both sides. Now I'm dividing by 5 on both sides. So now I get, as my final answer, x is all I'm left with, because these two things divide out to 1, equals 10 divided by 5 is 2. So my next step is, that's only part of my solution. Okay? I have 2 variables. I have x and y. I'm trying to figure out what is the value of both variables that satisfies both equations. So I know the x value is going to be 2 in both equations. I need to scroll back up and figure out what y is. Well, it says y equals x plus 1. So I could just say, okay, well, if y equals x plus 1, I'm going to kind of come over here to the right and solve for this. So if I know y equals x plus 1, and I know x is 2, well, then y is going to equal 2 plus 1. So y is going to equal 3. So the value that will solve both equations, or the value of x and y that will solve both equations, is going to be x equals 2, y equals 3. And just to prove that, I can come back up. So my equation was y equals x plus 1, 3x plus 2y equals 12. So y equals x plus 1. I'm going to skip a little room. Y equals x plus 1. Actually, I'll just plug in the 2 here. So if I plug in 2 for x, I get plus 1. And then I said y was going to be 3. Does that work? Yep. 3 equals 3. Well, my other equation, I'll change colors, was 3x plus 2y equals 12. Again, if I plug in x, or 2 for x and 3 for y, this should be correct. The left side should be 12, because that's what the right side is. So I say 3 times, I say x plus 2, so 3 times 2 plus 2 times 3 better equal 12. So if I solve out, that will be 6 plus 6 equals 12. Is that correct? Yes. 6 plus 6 equals 12, which means 12 equals 12. So the value of x and y, the one and only combination, the one and only ordered pair, if you will. So I could write it as this. It would be x was 2, y, whoops, x was 2, y was 3. That is the one and only ordered pair. That's my x, that's my y. The one and only ordered pair, the one and only value of x and y that fits and makes both equations true. So that's what we're solving or that's what we're doing when it says solving a system of equations. We're coming up with that one combination of x and y, that one ordered pair that will work for both equations.